4.2, which is rate of change and slope. So rate of change of a linear function, the rate of change is how a quantity is changing with respect to a change in another quantity. If x is the independent variable and y is the dependent variable, then rate of change equals change in y over change in x. So the typical formula that most schools use, or most textbooks, is going to be y2 minus y1 over x2 minus x1. Now, I like to think of it as whatever you're subtracting for your x first is what you're also subtracting with your y first. So you have to keep your points matched up. So that'll make a little bit more sense once we get into an actual example. So like here, it says find the rate of change of a function by using 2 points from the table. So I want you to pick any 2 points here. The 2 points I'm going to go with are going to be the first and second one. So if I put 24 first, because it's y over x, if I put 24 first on top, then I have to put its x first on the bottom, so like 4. So then I would take minus 12, so then I have to take minus 2. So if I do this, 24 minus 12 is 12, 4 minus 2 is 2, and if I divide those, I get 6. So the rate of change here would be 6 pancakes per cup of flour. So that would be our rate of change here. Every time we add in a cup of flour, it makes 6 more pancakes. So example 2 wants us to go ahead and compare rates of change. So the Jackson High School Student Council budget varies based on the fundraising of the previous year. So part A here says find the rate of change for 2000 to 2005 and describe its meaning in the context of the situation. So 2000 to 2005, if I follow that up, that's going to be these two values. So remember, it's change in y over change in x. So if I put 16,000 or 1,675 first, I have to put the year that matched up with it first, which was 2005, minus my other point. So 1,350 minus 2,000. So I would get 5 on the bottom because that would be my denominator. If I subtract those numbers up top, I get 325. So if I divide these, I'm going to get 65. Now it says describe its meaning in this context. So that means we're going to get $65 and it's going up. So an increase. So the budget increases $65 per year, and that's for those 5 years. Okay, so that's what that part of the graph is showing. It's showing that each year for those 5 years it went up $65. So now we would go into answering part B. So I have to scroll down a little bit more. So for part B, it wants us to find the rate of change for 2010 to 2015. So for this problem, my 2010 is here, 2015 is here. So let's say I put the 1,550 on top first. I have to put the corresponding year first on the bottom, so 2010. The other Y amount was 1,325, and our other year was 2015. So when we subtract this, we're going to get a negative 5 on the bottom, because 2015 is bigger, and on top, we're going to get 225. So when we divide this, we get a negative 45. So since this is negative and this is about budget, this is representing a decrease. So when I go to write this out, I would say the budget decreases $45 per year, and that would be for those 5 years. Okay, so the first part, part A, had an increase because we got a positive number when we did rate of change, but part B had a negative number, so it represented a decrease. So then we can go ahead and go over to this next part where it wants us to see if we have a constant rate of change. So I gotta explain this part here that'll help us get to that. So it says, determine whether the function is linear. If it is, state the rate of change. So we kind of already did something like this back in Unit 3. We have to see what our x's and y's are changing by and if we can get a constant rate. So when I look at this one, 11 to 8 is going to be subtracting 3. 8 to 5 is subtracting 3. 5 to 2 is subtracting 3. And 2 to 1 is subtracting 3. So I do the same thing with my y's. To go from negative 5 to 3, that's adding 2. To go from negative 3 to negative 1, that's adding 2. To go from negative 1 to 1, that's adding 2. And to go from 1 to 3, that is adding 2. So if I look at this, they did in fact change. The x's all by the same number, our y's all in the same number, which means this is linear. Now to find out what the rate of change is, remember it's change in y over change in x, which I had was a positive 2 and a negative 3. So overall, that rate would be a negative 2/3. Okay. So then we're going to do the same thing here with example 4. We're going to see if we can get a constant rate of change there. So when I look at this one, this is increasing by 7. This increases by 7. This part here increases by 7. And this part here increases by 7. So our x did increase by 7 each time. So then we go look at our y. So this is adding 3. This only adds 2. Right here, I automatically have that it doesn't stay the same. So this means it is nonlinear. And that would be because it's not constant. So we don't have a rate of change there. Okay. Now, rate of change is the same as slope. So that's why they tie these two together. So here's our slope. So slope of a line. The slope of a line is the rate of change in the y coordinates, so your rise, for the corresponding change in the x values run. So this is that formula I gave you. So the slope of a non-vertical line is the ratio of rise to run. So how far you go up or down over how far you go left to right. Okay. So I'll show you the formula method and the counting method for this. So it says the slope of a line can show how a quantity changes over time. When finding the slope of a line that represents a real-world situation, it is often referred to as rate of change. So this is just telling you slope, rate of change, same exact thing. Okay, so we're going to go ahead and get into these few examples we have here. So this first one, we're going to go ahead and do the formula part first. So it's our change in y over change in x. So whatever y we put first, we put its x first. So if I put 7 first, I have to put its x of 1 first. So this would be minus 4, which means this bottom part has to be minus negative 3. 7 minus 4 is 3. 1 minus a negative 3 is a positive 4. So this got me a slope of 3/4. Now I also could have used my graph to get that. because if I look at how far I have to go up and over. So to go from the points, if I'm going up, that's 1, 2, 3. So a total of 3 boxes. And then to go over, that's 1, 2, 3, 4. So 4 boxes. Up is a positive direction, and right is a positive direction, which would give me a positive 3/4. Now we can also do the same thing if we have a negative slope. So we're going to go ahead and do the formula, and then I'll show you the counting method. So if I take 3 first for my y's, I have to take its x first, which is -1. So my other y is 1. My other x is 4. So I have 3 minus 1, which is 2. -1 minus 4, which is a -5, meaning my slope is -2/5. Okay. Now I also could have counted that. So this would be up 2, but this would be a left 5, which makes it -5. So also getting me that negative slope. Horizontal lines. So horizontal line, I'm going to show you the formula method and the counting. So if I put -5 first, they both have a y of -5. So it technically doesn't matter which x I put first. So -2 minus 4. So a -5 minus a -5 is 0. -2 minus 4 is -6. Which, if I take 0 divided by anything, that's just 0. So I got my slope as 0. If I go to try and count from point to point here, I am going up or down 0 units. So I don't have a rise, but I do have a run, and that run would be 6. Depending on which way you look at it, it's going to be positive or negative, but since it's 0 divided by that number, it's just going to be 0, which doesn't have a sign anyways. Then we can have cases where it is going to be a vertical line. So we had our horizontal one, now we have this vertical. So let me zoom out a little bit. So it says find the slope, so we'll do our y minus y. So 4 minus -2. The x for my 4 was -3. The x for my -2 was -3. 4 minus -2 is 6. -3 minus -3 is 0. You cannot divide by 0, meaning this slope is called undefined. Okay. So when I go to count my rise and run, I can count up my 6. The problem is, if I try to go left or right, it doesn't move, so that's 0. So once again, since we can't divide by 0, that slope is called undefined. Now the next part allows us to use slope to find a missing value. Okay, so we're going to go ahead, set up our slope formula, and go from there. So slope, remember, is change in y over change in x. So for my y's, I have 5 and r, so 5 minus r. The x with my 5 is -4, minus the x from my r, which is 4. And that has to equal the slope we have here. So 3/4. So I'm going to go ahead and simplify this. If I take a -4 minus 4, that's going to be -8. And I need to get this to equal 3/4. Now, what this is showing us is that I need to figure out what I can multiply that 4 by to get my denominators to be the same. So I'm going to go ahead and multiply this fraction on my right hand side by -1, or -2, sorry, on top and bottom. Okay, so this would become 5 minus r over -8 equals -6 over -8. So now we just have to solve this numerator. So 5 minus r has to in some way be negative 6. So I would subtract 5 from both sides. That leaves me with negative r. Negative 6 minus 5 is negative 11. So I have to divide both sides by negative 1, leaving me with r is 11. So that would be r. Now you also could have set it up as r minus 5. Then you would have only had to multiply that fraction by 2 instead of negative 2. But since I set it up, I needed it to be a negative 8 in the denominator instead of a positive 8. So the last example in 4.2 is here. What is the slope of the continental slope at Cape Hatteras? So here we have our 2 points. So we're going to be finding our slope again. So we're going to take y minus y over x minus x. So I took negative 65. So that'd be minus negative 2,700 over my x's, which are 75 minus 125. So if we go to solve this, negative 65 minus negative 2,700 is going to be a positive 2,635. 75 minus 125 is negative 50. And if I divide those, I get negative 52.7. So that would be the slope here. And that is it for the 4.2 notes.